Okay, we're in geometry, and we're going to talk about 3.8 and 3.9 together. This is actually, I gave you guys this. Well, you're going to get this in class. And I want to talk about the 4 points of concurrency and how to construct those. So the first of all, a point of concurrency is where more than 2 lines meet. So 3 lines meet right here in this concurrency. The first one we're going to talk about is the circumcenter. And the circumcenter is found by constructing all the perpendicular bisectors of this triangle. Just a refresher on how to do that. I'm going to go ahead and do just one. You guys are going to do the rest of these in class when we meet again. I'm going to do the perpendicular bisector of this side. Why did I turn the paper? Oh, I don't know. It's just one of those things. It's easier for me to do that. So remember, to do a perpendicular bisector, my compass has to be more than halfway, or open more than halfway that distance. I'm going to swing an arc above and below the line from each endpoint of the segment that I'm trying to bisect. And then using a straight edge, I'm going to connect this intersection with this one. Well, I need a longer straight edge. Okay, so that's the perpendicular bisector. And then you would do it, the perpendicular bisector for this side and the perpendicular bisector from this side. When you do that, you will note that the circumcenter is equidistant from each vertex, which means that it is the center of the circumscribed circle. What does that mean? Well, let me go ahead and finish the perpendicular bisectors. I think it'll make more sense when you see it. So now I'm going to find the perpendicular bisector of the side CB. Swing an arc above and below. And remember, your paper is going to be a mess when we're done doing this, because I want you to leave all the compass points behind so I can see that you're doing it correctly. Okay. And this is the same as that. And now I'm going to do the perpendicular bisector of AC. Swing an arc above and below. Sometimes it helps if you're doing a lot of these to use colored pencils, because otherwise it can get quite messy. There's the perpendicular bisector of that side. There's the circumcenter right there. Now, I want you to notice this point, that the circumcenter is equidistant to all of the vertices. And I can verify that with my compass. That distance is the same as that distance is the same as that distance. Well, guess what? That distance becomes the radius of the circle that I would have to make to circumscribe around that triangle. In other words, it's kind of light. The circle goes around the outside. It's circumscribed around that triangle. That's the circumscribed circle. All right. The next one we're going to talk about is the in-center. And the in-center is created by constructing all the angle bisectors. Okay, so remember to do the angle bisectors. We're just going to swing an arc. In fact, I'm going to go ahead and do that on all of them. So that part's done. I'm going to turn the paper a little bit. And then do intersecting arcs on the inside. There's that angle bisector. It's better to do these one at a time, otherwise you get lost about what you're doing. And then this one, I'm going to open this a little bit just so it's not so messy in there. I'm losing my ability to see what I'm doing. That intersection to that vertex right there is the in-center. The in-center is equidistant to the sides of the triangle. And it is the center of the inscribed circle. So if you look at the distance, if I were to measure the perpendicular distance from this to the side, these would all be the same. And that becomes the center of the circle that's going to fit directly inside the triangle. In other words, this circle is inscribed because these distances are all the same. Okay. All right, the third one that we're going to talk about is the centroid. The centroid is created by constructing all of the medians. The claim to fame of the centroid is this is the center of gravity of this triangle. There's another thing, we'll talk about it in a minute. Okay, so I'm going to do all the medians. Remember, the medians is I connect the vertex with the middle of the other side. And the way I find the middle of these sides is doing the perpendicular bisectors. Okay, so I want to find the middle of BC. And remember, I don't really have to draw the perpendicular bisector. I just want to know where it hits that spot. Whoops, sorry. I just want to know where it's going to intersect that line or that side. So I know that that's the same as that. And that particular median from A is right there. Okay, now I'm going to find the middle of AC. Swing an arc above and below. I might have to move my compass. That might not have been enough. Oh, perfect. Look at that. So this to this, line those up, connects right there. That's the middle of that side. So then the median B goes right there. And now I'm going to do the middle of that side, the perpendicular bisector of AB. Okay, so I might run out of room here. I'm just going to show you a little trick you can do. You just set another piece of paper underneath there. Oh, I didn't really need it anyway, because right there's the intersection. But that is a trick you can do in case that ever works out like that. So connect these two intersections. It would cross right there. And notice, okay, if that hadn't have been the point of concurrency for all three of them, I knew that something would be wrong if it doesn't actually do that. Okay, so the other thing that I want to talk about, let's see, this is M, we'll call that X. The other thing about this centroid is that XM is a third of the length of XA. In other words, if this were X, this length, the longer length is 2X. So if this length, let's say this length is 3 inches, 3 centimeters, whatever, this would be 6. If this was 4, this would be 8. Okay, and the last thing that we're going to talk about is the orthocenter. And the orthocenter is created when you construct all of the altitudes. And remember, the altitude is the segment that connects a vertex to the opposite side at right angles. That means I want to construct a perpendicular to this side through that point. Remember how to do that? We want our compass open so that when we cross the opposite side, no, that's not going to be enough. It crosses it twice. So it crosses here and here. All right. From those points, I'm going to swing an arc above and below so that the arcs intersect. And then I'm going to connect, sorry about that. I'm going to connect the vertex with that intersection point. And there's my altitude. Okay, I'm going to do that with all three vertices. Now I want you to notice that if I'm doing the altitude from B to AC, I'm going to have to extend my line right here because I'm not going to be able to cross it twice. So I'm going to do that in a different color so you can see it. I'm just going to make that side a little longer so that when I cross it, oops, I'm going to have to extend the other line too, aren't I? Okay, let's try that. Okay, so I've got it crosses there, and it crosses here. So now I have a place to put my compass. Make sure it's more than halfway, and I'm going to swing an arc above and below that line. Whoops. And I'm going to connect this intersection with that vertex to create that altitude. All right, one more. Why do I turn my paper? I think I've already explained this. It's easy for me to see if the vertex, what I'm supposed to do if the vertex is pointing up and the side is like this to me. You don't have to do that, but if it helps you, by all means, why not, right? I'm going to go ahead and extend this side just so I don't have to stop what I'm doing to do it later in case I need to. Because remember, I'm going to go from C, and I want to be able to cross this line twice. Okay, so there's the first time. And there's the second time. And now I'm going to take my compass and swing an arc above and below from each of those marks I just made. So here's that intersection. There's that vertex. And that's an altitude. And that is the orthocenter. Okay, I want you to practice. These will definitely be on the test. At least one or more of them. At least one of them is going to be on the test. So go ahead and practice. If I didn't give you one of these sheets, a blank one to practice on, go ahead and just recreate your own triangles. They don't even have to be like, it doesn't have to be an obtuse triangle. But I just want to know that you can find the circumcenter, the incenter, the centroid, and the orthocenter. And we'll definitely be practicing these next week at school too. All right, that's it for 3.8 and 3.9. Don't forget, we're skipping 3.7. 3.6 is nothing new. It's just using the constructions in the first 5 sections to do construction problems. And then don't forget to watch 3.5, which is constructing parallel lines. And that's it for chapter 3.